Okay, so in this second architecture, the edge device is not directly connected to the controller, but instead it interacts with an OPC server here. And we see it is directly interacting with the OPC server to pull the data. Now we see that the OPC server, the edge, is basically outside the network. Okay, so the edge is outside the network now, and we need to secure this communication path. So how we can do it by doing firewalls. Two firewalls can help us. The first firewall is going to uh, filter and secure all the HTTPS. So the firewall number one, it will filter, it will deal with the it will secure all HTTPS or TCP traffic, right, generated by the edge towards the OPC server. And this controls the import and output requests to ensure only that legitimate communications are allowed. And the firewall 2, number 2, is deployed between the edge and the internal network. And this second firewall is creating sort of like this overall makes DMZ, demilitarized zone, and this demilitarized zone acts as a buffer that isolates the edge from directly accessing the control and corporate network. So we have the plant network and the control network and the corporate network. So they are all properly secured through the firewalls. So in this setup ensures that the OPC UA client is running here. OPC UA client. It is running on edge. And this OPC UA client, which is running on edge, can securely request the data without risking any of the internal system security and integrity. So this layered approach, this is a layered approach. This layered approach allows a controlled access, and it reduces the exposure, and it helps to ensure the strict traffic rules across the network boundaries. Okay. So in this final point regarding the same architecture, this architecture 2, it is important to understand that when we deploy an OPC server, this is not enough only. So this requires a proper what you call the risk assessment. Okay, so the its deployment. Okay, so we are talking about okay, so we are talking about that in the when we talk about architecture 2, it is important that we understand that deploying the OPC server is not enough on its own, and we need we require uh, we require this setup. This setup requires the a proper risk analysis. Okay, and the analysis should focus This analysis should focus on, for example, the OPC UA security model. How much does this OPC security model is provided by the vendor, and it actually meets, does it meet the security needs of security needs of our specific industrial scenario. Okay, so if the built-in security model is insufficient or incomplete, then um, we need to and if it is not, and if not sufficient, the model is not sufficient, then we can then we can think, or we can deploy a deep packet inspection, DPI firewall between OPC UA server and control network. Control network. Okay, so this ensures that even if someone manages to exploit the edge to server communication, the core control infrastructure remains protected by this extra inspection barrier. So in summary, in summary, so in summary, the risk assessment, and layered defense strategy are essential to safely implement edge connectivity using OPC UA in industrial environment. Okay. Okay, now the third architecture. In this architecture, the edge device connects to an OPC server, which is running directly on PLC. We see that on the PLC we have a card with the OPC server installed on it, and then it is connected to direct to the edge as the OPC client. So this means that any communication from the edge goes straight to the control infrastructure. Now now since the edge device is located outside the control network, we must deploy a firewall to filter and secure the incoming HTTPS or TCP requests. So this is essential to protect the integrity of the network. But that's not all. We also need another firewall between the edge and the control network. Like we have this, but we also need another control network. We need to secure this area or communication. And so the goal is to create a dedicated DMZ zone for the edge deployment. And this ensures that all the traffic to and from the controller is inspected, filtered, and isolated properly. So here we have like a two-layer protection. Two-layer protection. And one is securing the data from the asset from the cloud, and the other is taking care of the guarding the control network. So if you see the from the control network, from the plant network, and the from corporate network until the cloud, we have firewalls installed there. Okay, we have firewalls, and these firewalls enable us to make like to put this edge device in a DMZ or demilitarized zone. So this architecture brings the benefit of direct access, but demands like a strong perimeter control to avoid any compromise of the control infrastructure. Now, in this architecture, there is no DPI firewall used to segregate the OPC US server from the control network, because communication is internal here, and it happens because of the internal network bus, which is directly connected to the OPC US server hosted in the controller. So now there are two important considerations, and these considerations are: number one is the platform security, and usually the OPC server is embedded. If the OPC server if OPC US server is embedded on the PLC in the controller. So this means that it is running on Linux based systems, Linux based environment. And we know Linux is more resilient OS and to the against these cyber threats. So it gives us this is a plus point for us. It gives us an advantage. The second thing is about the software firewall option. So even if there is no physical DPI firewall, we can configure a software file-based firewall on the Linux box itself. So this helps to ensure additional segregation between the OPC server and the rest of the controller network. And even if it's running internally through the controller bus, this architecture leverages the internal connectivity, but it still needs careful attention to platform hardening and internal control traffic. So this ends our topic on the cybersecurity in the industrial control systems. Thank you very much. The next recordings will be on analytics topic 5. Thank you.